Hello guys, my name is Engineer Ali. We want to solve these objective questions and we want to look at about 30 of them on rotational motion. It says, number one says, which of the following statement concerning the moment of inertia is or are true? Number one, Roman figure one, the kinetic energy of the body rotating about a fixed axis of moment of inertia I with angular velocity W is what? 1 over 2 I W square. That one is correct. The moment of inertia of a finite number of particles is always greater than the number of, or greater than numbers, it should be numbers greater than the infinite number of particles. Okay, I think that was correct. But it's not always greater. Rather, the infinite number of particle moment of inertia should be higher than what? Than the finite number of particles, because in an infinite number of particles, the number of particles involved are so numerous, and at that point, by the time you are looking for such moment of inertia of sum of all of them, it will be greater than the finite numbers. So I think I will go with what of moment of inertia depends on mass and distribution of the of the particles also. I think it will go with 1 and 3. So answer is C. We'll go with C. Number 2, say calculate the radius of gyration of a uniform rod. Now the radius of gyration of a uniform rod of mass m and length 2a about an axis through the center and perpendicular to the rod if the mass of the rod is 20 kg and length is what? 6 meter. So what we're going to do now is what? The moment of inertia is equal to 1 over 12 ml square. Now don't forget that it's through the center. Through the center is 1 over 12 ml square. Through the what? The axis or the ends is 1 over 3 ml square. So we have our length. Our length is given as 2a. So then what again? We have our mass. Mass is equal to what? 20 kg. Then the length is 6 meter. So what we're going to do is to find the radius of gyration is to what? Mk square, which is the moment of inertia of any shape, go to what? 1 over 12 ml square, because we are talking about moment of a rod about the center. This one comes with this. We are going to have k square equal to 1 over 12 l square. So take square root of both sides. Take square root of both sides, we are going to have what? It implies that k will be equal to what? L over square root of 12. And square root of 12 is simply as what? L over 2 root 3. So in that case, we are going to have it as L over 2 root 3 times 1 over 3. So now, what we're going to do now is to rationalize what I'm trying to do, because 12 is simply as 2 root 3. So we have what? Root L over 6 over 6. Now, what I notice here is that since we have we have 1 over 12 ml square, which have been solved, then if you take the square root of that one, what do you have? The mass is, the length is 6. Okay, I did not use the length. The length is 6. Root 3 over 6 times 6. So this one will cancel this one. We're going to have what? Root 3. So the answer is A. It is only when you are not given what? Length that you use what? You use L. Your answer will be in form of L. So, but since your answer is not what L is given, use your L to be 6, then you get your final answer. So 6 divided by 6 will give us 1. 1 times root 3 will give us root 3. I'll go with option A. Let's go to question 3. A disk of moment of inertia, the 2 times 10 by 2 kilogram a meter square, is rotating freely. Now, Then I say what? Then I say what? Rotating freely about an axis O through the center of 20 with what? 20 meter per second. Calculate the new angular frequency if the sum of candle wax of mass is dropped gently on the disc 0.1 meter from the axis. Now, what I want to do here is simply what? Take our parameter. Now, let me solve it here. Now, our mass, check, yeah, the mass is what? The I. So, let's solve now. This one said I equals to what? 2 times 10 raised power 2. So if I is 2 times 10 raised power 2, then our W is what? 20 rad per second. That's what they gave us. That is what is rotating with. That means that the disc is initially was what? Rotating with what? Angular velocity of W and moment of inertia I before it was dropped. Then after collision, the candle was dropped on top of the disc. And when they drop it, what happened? Look at the board. The candle was dropped here. Look at the book now. Now, let's say for where the candle was dropped to the center of rotation is what? 0.1 meter they give us. And the mass of the candle wax is 0.05. Because if you check, see, calculate the new angular frequency, which is angular velocity. If some wax of candle of mass, this is the candle mass, and is dropped gently on the disc 0.1 meter from the axis. So in that case now, what I'm going to do now is initially I1 W1 equal to what? Then after the candle wax was dropped, we now have the I plus what? The moment of inertia of the candle wax, which is what? M mass times what is the distance from where the candle wax is dropped to the center is what? Let's call it H square. That is the moment of inertia of the candle wax. Then combine, because the two of them, after they what? You drop the candle wax on top of the disc, you expect them to be moving with the same what? Angular what? Frequency, which is what? This W, the new what? Angular frequency that we are looking for. So omega nu. So what I want to do now is what? Omega nu equal to what? I1 W1 over I1 plus MH square, all what? Bracket. So this is what we are going to use to solve our problem. Let's substitute everything inside. So we are going to have I1 is what? 2 times 10 from what? 2 times the angular velocity, initial angular velocity that the candle house was moving with was what? They gave us as 20. So times 20 divided by what? The moment of inertia of the candle wax that we are looking for, that we already given, is 2 times 10 to the power 2 plus the mass is what? 0.05 times what is the distance from here to this place? 0.1 was square. So finally, we are going to have this times 20 divided by 10 to the power 2 plus 0.5 0.05 times 0.1 square. let me do it this way. 2 times 10 raised to the power 2 times 20, then the 0.05 times 0.1 square plus 2 times 10 raised to the power 2, close the bracket here, then close the bracket here, open the bracket here, 19.99 rad per second, which is approximately what, 20 rad per second. So let me, if you confirm it, if you say you want to confirm it, okay, 20 times, to be sure, 10 raised to the power what, 2 times 20, that is this one now, 4,000, 40,000. Then we have 0.05 times 0.1 square. 1 square is 0.005, then plus 2 times 10 raised to the power, which is 2 times 10 raised to the power what, 2, 200. So if you add it to what, 0.0005, then 40,000 divided by answer, that is 40,000. So this is 4,000. So this one will now give us 2 zeros plus 0.0005. So 4,000 divided by answer, 19.99, which approximately 20. So in that case now, I will go with none of the above. None of the above. Let's go to number 3. Number 3 question. Number 4, rather. It said a thin ring of 50 gram and radius 5 centimeter is spinning at frequency of the spring. The thin ring of mass and radius is spinning at frequency of the spring. Now, what they are trying to tell us to solve here now is that because they give us mass, give us radius, now see at the frequency of this is not complete. So the question is supposed to be what? A thin mass 50 gram and radius 5 centimeter is spinning at frequency of 6 revolution per second. That's it. Then it should be what? When a mass of 75 gram is added uniformly, what is the final spinning? So that's what is supposed to be the question. Now this one now is a thin ring of mass 50 kg. That means the mass is of 50 kg or 50 gram rather, and radius of what, 5 centimeter, is spinning at what, a frequency of this frequency. That means frequency of 6 revolution per second. Now see, what is what that is when a mass of this is added uniformly. That means when you add the mass of 75 kilogram to it, what will now be the what, the spinning what, frequency. So what we're going to do now is to what? To know when this, what will happen to the spinning. You understand me now? When the what? So we are going to have a 75 gram. When the what? Because we know that what? I1 W1 should be equal to what? I2 W2. And I is what? M1 R1 square. Then 2 pi F1 equal to what? M2 R2 times square times 2 pi F2. So if this one cancel this, then we have what? R1 square, R2 square. So what we have now is 50 times R2 now is what? R1 is 5 centimeters square, is times what? What is the frequency? Then equal to what? What is our M2? M2 will now, this is M1. M2 will be equal to 50 plus 75, which is equal to what? 125 kilogram. Don't forget that they said it was added to the ring. So there will be an additional mass of 75 gram added to the 50 grams. So I would have 125, and the radius R1 is equal to R2. So in that case, our R is still the same thing, 5 centimeters square times F2. So if you make F2 the subject of formula, this one will cancel this one. So what we want to have is 5 times 60 times 6. 50 times 60 divided by what? 125. So what do we have? So what we want to have is 2.4 revolution per second, which is approximately what? 20 rev per second. So that will be our answer, B. Now this one says the angle suspended. Number 5, the angle suspended by an object with the center of a circle when it is moving from one point to another is from one point to another on its circumference is called dash. Now what we want to know now here is that we want to the angle suspended by an object with the center of a circle when it is moving from one point to another on its circumference is called, we can call it what? Angular what? Displacement. So the answer to that question should be what? Angular displacement. Because when you move from one point, is a circle, for instance, a sketch, and it move from one point here to another, there will be what? Let's say point A to point B along the circumference of a circle. This is a rough sketch of a circle. Now this what? Circle now, the point from here to here produce an angular displacement called theta. And that angular displacement divided by the time it takes to go from A to B is what we call angular velocity. So this one is what? The angular what? Displacement as the answer. Number 6. You say which of this is correct expression for finding the kinetic energy of a solid cylinder with velocity v? Which of the following is what? The correct what? Which of the following expression for finding kinetic energy of a solid cylinder of mass m with speed v if it has a radius of r? Now what we want to do now is what? The kinetic energy for finding what? A solid cylinder that will now be what? 1 over 2 mv square plus 1 over 2 I W square. Because this is a formula to use to solve for the kinetic energy of a solid cylinder. Don't forget, when the solid cylinder is rotating, it go with what? Two what? Energy. We call it the translational kinetic energy and rotational kinetic energy. And the moment of inertia I of a solid cylinder is 1/2 mr square. So that's what we want to use for our I here. So we're going to have it as 1/2 mv square plus 1/2 times 1/2 mr square w square. Don't forget, I is what? This now. This is I. Then the w square will be dropped down. Now don't forget that v equal to omega r. And that means v square is equal to what? Omega square r square. That means this place will be replaced with v. So I want to have it 1/2 mv square plus what? 1/4 mv square will now give us what? What is the LCM? LCM is 4. 4 divided by 2 is what? 2 times mv square. We have 2 mv square plus 4 divided by 4 is 1. 1 times mv square gives us mv square. So, ladies and gentlemen, the final answer to this question is what? 3v mv square over what? Over 4. And that will be option D. The next question says what? A rotating cylinder about it as a through the center can be analyzed using what? The conservation of angular momentum. Because anything that has to do with the concept of what? The rotation of a body. When that has to do with rotation of a solid cylinder about it as a through the center can be fully analyzed by what? By conservation of angular momentum. Which says that what? The angular momentum, the total angular momentum of a system is constant. Now let's go to the next question, which is question 8. It says calculate the moment of inertia. Calculate the moment of inertia. The question should not be calculate the moment of it, should be what? Okay, let's see. Calculate the moment of inertia and the radius of gyration. They are now giving us moment of inertia of, that means it's a rod then about its center. Radius of gyration of a uniform rod is a length of length L about an axis through the center perpendicular to the rod if the mass 20 kg and length 6 meters. Okay, they've already given us the moment of inertia, because I was shocked why they gave us moment of inertia of, and they say we should calculate it, giving us even make it easy. So 1/12 ms square through the center. In some exam like that, they will not give it to you. This one is like a bonus given to us. So it's like a bonus. So this one is not supposed to be given to us. Now what we want to do now is times what is the mass? The mass is 20 times what is our length? 6 square. So what I want to have now is 1/12 times 120 times 36. So what do we have as our answer there? So 120 times what? 36 divided by 12. So we want to have it as what? 360. Okay, let's not forget that the length is to 6, the mass is 20. So what we are looking for now is what? The moment of inertia. So if you multiply what? 20, okay, I use 120, it's 20, sorry, 20 times 36 divided by 12. That means the mass is 20, the length is 6. Then you just what? 6 square is 36. 36 times 20 will give us what? 36 times 20 times 20 gave us what? 720 divided by 12. We have 60 kg in that square. Then what are we looking for now? We are looking for radius of gyration. Mk square is equals to what? 1/12 ml square. And in this case now, for us to find that We need to find K. K is our radius of gyration. And everything, let me say everything here is 60. No need to waste my time there. So for me to find K will now be what? 60 divided by mass, the square root of everything. That's what I would have asked to make it a subject of formula. So 60 divided by what? What is the mass? 20. So we are going to have square root of 3, which is same as 1.7321. And our answer should be what? 1.73 meter. So our moment of inertia is 60 kg meter square, while the what K is what? 1.73 meter. So which answer is closer to that? 60 and what? This is 60 and 1.72 wrong. 50 and 1.73. 60 and 1.3. I will go for none of the above. Number 9. It said what? The angular momentum of a rotating flywheel gives one of the following. Flywheel gives one of the following, or is given as one of the following. So that means the angular momentum, linear momentum is equals to what? Linear momentum. Let me use P. Permit me to use P. Linear momentum is equal to mass times velocity. While angular momentum should be equal to what is mass in rotational motion? I times what is in, if linear velocity is V, what is angular velocity? That is W. So mass times what? Velocity is for what? Angular momentum. So angular momentum is moment of inertia times what? Angular velocity, which can be written as what? Mk square for any shape times 2 pi f. For don't forget that omega is the same as 2 pi n over t, and also the same as 2 pi f or 2 pi over period. So that is just that. So the answer to that question is C. A particle is moving in a circle of radius 0.5 meter with an angular what? Velocity and tangential velocity of what? What is angular velocity? Omega is equal to what? 1.5 rad per second. Then tangential velocity of what? 0.75 meter per second. Then what they say we should find? If the angular what? Acceleration, how far is equal to what? 40 rad per second square. They say determine the linear acceleration. Don't forget, linear acceleration is equal to square root of what? Tangential acceleration plus what? Centimeter acceleration square or square root. Tangential acceleration square plus centimeter acceleration square or square root is equal to that. What is centimeter acceleration? Is omega square r or omega v or what? Omega what? You can say v square over r. Any of them is better. Now let's choose one. Okay, let me use what? 1.5 square times what? R. What is our R? 0.5 to get centimeters. You get that one? Then tangential acceleration is equal to what? Alpha r. What is alpha? 40 times what? 40 times radius, which is 0.5, which is what? 20 meter per second. This one is what? Tangential centimeter acceleration is what? Is 1.5 square times 0.5. We would have 1.125 meter per second. So we now use to get our linear acceleration. We are going to have what? Square root of what? Tangential is 20 square. Linear is 1.125. So what do we now have as our square? As our final answer. So square root of 20 square plus 1 square of what? 1.125 square. So what do we have? 20. Oh, this is not 20. This is 4.0. So here we're going to be 2. It's 4.0. It's 2.0. Sorry. 2 point. This is 4.0, not 40. Because the value is big. It's too big compared to this. And so 2.0 square plus 1.125 square. Then square root of everything should be giving us what? 2.2946 meter per second. So that will be your answer. The next one says number 11. You measure the length of a distance car at angular distance of what? Of 2.0 degree. That is theta. Now, this 2.0 degree convert to radian is what? 2 point what? In radian now be 2.0 degree times pi over 1/8. That will give us pi over 90. Now, right. Our S is giving us, what is our S? Our S is what? Say if the car is actually 5 meter long, that is actual length. What is the radius? So R will now be equals to what? Don't forget that I gave you, there is a formula that says theta R. Distance is equals to what? That means actual distance is equal to what? Angular distance times what? The distance it takes to what? A car. How long will it take for the car? This R. So in that is this R that is the distance covered by the car. It will now be what? Solved by what? S over theta. So if it's S over theta, S is 5, theta is pi over 90. So this one, this 90 can go up as 5 times 90 divided by pi. So what will now be our final answer to get the what? The R. Because R is how far away, approximately how far away is the car. So the distance of the car. So R can also be likened to be your radius. So if you what, depending on the context of the question. So this one will now be what? Our answer is equal to what? 143.2, which is approximately what? 1.43 times 10 raised to power 2 meter. So in that case, what we have solved now is the closest answer, which is said as 1.4 times approximately 10 raised to power 2 meter, is what? Option A. Now the next question says, if the output of a grinding machine is 100 watt horsepower. Now it says that what? At what? 3,000 revolution per minute. What is the torque expended by the car or by the machine? By the machine. If the output of the grinding machine is 100 horsepower. Now horsepower is a unit of what? Of power. But we can actually convert it to what? To watt. And we can convert, how do we convert it to watt? Simply what? Just take your what? Your horsepower and multiply it by what? By, let's say, 100 horsepower. If 1 horsepower if you are using calculator like this, for example, now you can even convert it. Look at it here. For those of you in higher institution, 1 horsepower, you can, if you are using Casio, you can convert it easily. Just press shift. Look at it. Shift. That means shift what? 8. If you are using on convert, then you press 29. Then that means 1 horsepower to kilowatt. is equivalent to what? That means 1 horsepower to kilowatt is equivalent to 0.7457 kilowatt. So 1 horsepower is equivalent to what? 0.7457 kilowatt. So what will now be 100 what? Horsepower. So you can cross multiply. That means 100 horsepower should be what? 74.557 kilowatt. That's what it means for what? 100 horsepower. If 1 horsepower is equal to this, you can always convert it. Just press shift 8 0. That means 29. Shift then 29. You see, but you can now put the value at the back. If it's 2 horsepower, you want to collect 1 horsepower, you can put it at the back, then you convert. Now, having done that, now it makes our work very easy now. So we know that power is equal to torque times angular what? Velocity. Tau equal to angular times angular velocity is equal to what? What power. Now we have gotten our power to be equal to 4.57 as our power kilowatts is equal to what is torque or known times what is our angular velocity. We can solve it out by what? 2 pi is 3000 divided by what? By 60. Don't forget that angular velocity equal to 2 pi n over 60 if you are given in rev per minute, if your n is in rev per minute. That's why I use this formula. So what I want to have now is I will make tau the subject of formula. What do you do? 74.57 times 1000 times 60, cross multiply. This 60 will go there. Then divide by what? 2 pi times 3000. So if you do that, you get our value for what? For torque, 74.57 times 1000 times 60. Convert to kilo is 1000. That's why I multiply by 1000. Then times 60 divided by 2 pi times 3000. So I would have 237.36. 237.36. So 363. And what we have here is 237.6. So I'll go for none of the above. Number 14. A flywheel of mass 1000 kilogram, which is about 1 tons, and radius of gyration is 3 meter. It's rotating once every seconds. So I want to have it as what? Frequency as what? 1 rev per second, once every second. The kinetic energy is equal to what? Kinetic energy is equal to 1 over 2 omega square. So that will give us 1 over 2 times what? I times 2 pi f all square. It's set as 1 over 2 I what? 2 pi n over t all square. So we put it our value there, we substitute our value, then we'll get our final answer. So what I want to get now is simply what? Just what? Don't forget that flywheel, moment of inertia of a flywheel, I is equal to what? 1 over 2 mr square. Circular flywheel, circular wheel, flywheel, solid cylinder, they are 1 over 2 mr square. And it's equal to what? Mk square. Since we are giving what? All the shape have mk square, where k is radius of gyration. So we can use it as what? The mass, which is 1000, times k square, which is 3 square, will give us what? 9000. So we use our I as 9000. So now, having gotten that, So this one is what we use with no uses, because the radius given to us is not normal radius, the radius of gyration, which is k. So what I want to do now is to use our formula 1/2 9,000, which is your I, times, if you check, we have 2 pi after 1/2 I, which is 9,000, times 2 pi n over t squared. That means now give us what? 2 pi. N is what? What is our n? The n is what? 1 ref. Once every seconds. Rotating once every second. So one is frequency over what? 1 all square. So the kinetic energy now will now be what? What will now be our kinetic energy? And 1/2 times 9,000 times 4 pi square. Because square of 2 is 4, 12 pi is pi square. So we want to have it as what? 9,000 times what? 4 divided by 2. So our answer should be giving us what? 18,000 pi square joules. So that's what we want to have. 18,000 pi square joules. Option C is 18,000. 18,000 pi square joules is option C. So C is the answer. So option A is 4,000 pi square joules. B is 18,000 pi square joules. C is 9,000 pi square joules. D 9,000 pi square joules. And E is what? None of the above. So the answer is what? C. So option C. Now they go to what? Number 15. Number 15 says calculate the moment of inertia of a 3 kg sphere of diameter 15 centimeter about an axis through the center if the speed is a solid what? If the shape is a solid sphere. Calculate the moment of inertia of a 3 kg sphere of diameter 50 centimeter about an axis through the center if the speed is a solid sphere. I mean the shape. And I don't think we need that one again. What you are supposed to tell us is that if what? If the sphere is a solid sphere. So that's what they are supposed to tell us. Now, if a sphere is a solid sphere, this sphere, because we have a spherical shell, we have a solid sphere. Now, a solid sphere, the moment of inertia of a solid sphere is 2/5 mr square. 2/5 mr square. That is the moment of inertia of a what? A solid sphere. Now, don't forget that radius is equal to diameter divided by 2. So what is diameter now? Diameter is 50 centimeter divided by 2. We are going to have what? 25 here. So we are going to have 2/5 times. What is the mass? Times what is diameter? 25 times 10 to the power minus 2 all square. So that is our diameter. Now what I want to have now? I want to have it as what? 2 divided by 5, then times 3 times 25 times 10 to the power minus 2 all square. So what we want to have now is what? 0.075 as our answer. Kg meter square as unit. So we are going to go with option D. Number 16 said a uniform solid cylinder rotating about its center axis have a mass of this 2 kg of 2,000 rad per second. Calculate its rotational kinetic energy if its radius is 0.24. Radius is 0.24. R is 0.24. Mass is what? 2 kg. Angular velocity is 200 rad per second. So we are calculating what rotational kinetic energy, which is what Kr is equal to 1 over 2 I omega square. So 1 over 2, what is a solid cylinder? Solid cylinder is 1 over 2 mr square. So we'll put our value there. Now become 1 over 4 mr square. So I want to have it as what? Times what? Don't forget there is omega. Omega square. There's omega square by the side. Omega square. So let's put in all our parameters. So we are going to have it as what? 1 over 4 times. What is the mass? 2 times. What is our radius? Radius is 0.24 square times. What is our angular velocity? 2 pi. Okay, we are giving as 200, so no need. 200 all square. What else do we need? I don't think we need any other thing again. So what we just need to do is to what? We'll press our calculator. 1 divided by 4 times 2, which is 2 is mass, times what? 0.24, which is the radius given to us, times and don't forget the formula for rotational motion. Rotational kinetic energy is half I W square. So times what? 200 square. So we have 1152. 1152. So that's what we are supposed to have. 1152. Let's confirm it again. The radius is what? 0.24. The mass is 2 kg. The okay, let's see, 200 square is times 0.24 times 0.24. What we just be sure, times 2 divided by 4. Okay, 1152. So 1152 joules will be our answer. So if you have 1152 joules as our answer, then that means we'll go for none of the above. 152 joules. Number 17. Number 17 is what? A disk of moment of inertia. Number 17. A disk of moment of inertia, 5 times 10 power minus 4 kg meter square, is rotating about an axis through the center at 40 revolution. Calculate the new revolution per minute if some candle watts of this is dropped gently at. I think we have solved this one before. The angular velocity of the new one is equal to what? The angular velocity, the moment of inertia of the disk, angular velocity of the disk before the candle was dropped, over angular velocity and the moment of inertia of the disk itself, times mass times h. H square is the distance from where the wax drop to the center or to the axis of what? Of rotation, which is what we are looking for now. That is the formula. I've used this formula before. So this one is what? I, which is moment of inertia, is 5 times 10 to power minus 4 times angular velocity. You don't need to convert it. Just leave it. See, our answers are in what? Rev per minute. So just put it 40 divided by what? Moment of inertia of the what? Of the body is 5 times 10 to power minus 4 plus the mass of the candle wax is what? 0.2 of the wax times what is the h, where they say it will drop gently on the disk, 0.08 from the each axis, so 0.08 square. So what I want to solve now will be giving us our answer for the what? The in rev per minute. So I want to have it as what? Minus 4. Okay, let me do it this way. That means 5 times 10 to the power minus 4 times 40 then divide by what? What do you have? 5. Let's open your bracket. 5 times 10 to the power minus 4. Then times 0.2 is plus 0.2 times what? 0.08 square. Let me just do the numerator first separately. I think that would be better. Let me do the numerator first. I don't want to have any wrong answer here. Minus 4 times 40 times 10 times 40. I would have 0.02 divided by what? Then 5 times 10 to the power minus 4 plus 0.2 times 0.08 square. So that will give us what? Then 0.02 divided by what? Answer. So what I would have is what? 11.23. 11.23, which is our answer for that question. Let me check again for the last time so that we can be sure. 11 point this thing. Then let's check. Let's do the word like this. 0.02 0.2 times what? 0.08 square. Okay, plus 5 times 10 to the power minus 4. So I would have it as what? 1.78 times 10 to the power minus 3. Okay, let's do the numerator times 40, 0.02. So what do we have now? Divide by 1.78 times 10 to the power of minus 3. Close the bracket. So I want to have 11.23. That means we are sure now. So that is approximately 11. So the answer is what? E. So not 33. Please, let's be careful when we are using the calculator so that will not be what? Solving the wrong thing. Then this one says what? In the rotational what motion, the quantity summation mr, which correspond to the mass of the body in a linear motion, is called dash. In a rotational motion, the quantity this, which is corresponding to the mass of a body in a linear motion, is moment of inertia. 19. What is the kinetic energy of a rotating cylinder about its axis at a fixed point of mass m and moment of inertia I? The kinetic energy is equal to what? 1 over 2 mv square plus 1 over 2 I omega square. That's the kinetic energy of a rotating cylinder. So 1 over what? Mv square plus what? 1 over what is the moment of inertia of a solid cylinder? 1 over 2 mr square, then w square. Remember that this one, this 2 is equivalent to w square r square equal to v square. Recall that v equal to omega r, and that means wr, angular velocity times radius. Therefore, what we're going to have now is 1 over 4 mv square plus 1 over 2 mv square plus 1 over 4 r. 1 times 1 is 1, 2 times 2 is 4. Then in place of these 2, I will place what? So if you add them together, we have done something like this. Will give us what? 3 mv square over 4 is 3 over 4 mv square. But don't forget that this is rotational kinetic energy, while this is translational kinetic energy. If they had asked me what is the rotational kinetic energy of a rotating cylinder about an about its axis at a fixed point of mass m and moment of inertia I. I will have used only this to solve that question. Then let's go to number 20. So which of these is option for finding the kinetic energy of a solid cylinder rotating at a constant speed? If it's rotating at a constant speed, that means this velocity will be zero. This velocity will be zero. That means acceleration will be zero rather. Then it will not move from one point to another. And if it does not move from one point to another, it means this will be zero. Because for a body to move with a constant speed or constant velocity, the translational kinetic energy becomes what? Zero. And in that case, we will now say that only what will exist is just this one. So our answer will not be what? This particular answer. Remember, because they say what? Constant speed. 21. It said a uniform flywheel of mass 64 kilogram and radius 1 meter start from rest. So initial velocity is equal to what? Is equal to 0 rad per second and rotate under the action of constant torque couple, making 40 revolutions. And the theta is equal to what? 2 pi n, and n is 400 revolution. Its angular what? Speed, omega. Angular speed is what? 40 rev per second. That means I have to convert this to rad per second, which is 2 pi times 40 over 1, and that will give us 80 pi rad per second. Okay, so find the moment of inertia, find the moment of the couple. Moment of the couple. Okay, we have the F final, we have the F initial. We know that moment of the couple tau is equal to I alpha. And we need alpha. If you can get alpha, we can get. Remember that our theta, it will now be equal to 2 pi n is 400. Will now give us what? 800 pi. Take note of that. Then the formula to use, I know my theta, which is angular displacement. I know W, I know what? Final and W initial. So I can use W final square, W initial square minus 2 alpha theta. Why am I using plus? Why am I using plus? Because it's starting from rest. It's accelerating with an angular or constant angular acceleration. So this one will now be what? 80 pi all square equal to 0 square plus what? 2 pi alpha times what? 800 pi. So how do we make alpha the subject of formula? We have 80 pi all square divided by what? 2 times 800 pi. So what do we have as our answer there? We're going to have 80 pi square, then the 2 times what? 800 pi. What do you have? We have 4 pi. Now, after getting your 4 pi, that is not our answer. We are looking for tau. Tau equal to what? Moment of inertia times alpha. Now, are we giving moment of inertia of a circular flywheel? We can solve it. Moment of inertia of a circular flywheel is 1 over 2 mr square, which is equal to 1 over 2 times mass is 64 times moment of radius is 1 square. So let's solve that one first. What do we have? 64 times 1 square divided by what? 2. 32 kg meter square. So we put it here. So that means our tau will now be 32 kg meter square times 4 pi. So our answer will multiply by 4 pi now times 4 pi. That is 128 pi. Our answer is 128 pi Newton meter. So we go to the option that have 128 pi Newton meter. I don't think the answer is yes, so we are go what with E. Go to next question. 22. 22 says that a pulley rotates with a constant frequency of 500 revolutions per minute. If the what? It has a moment of inertia of 6. So moment of inertia is what? 6.5 kilogram meter what? Square. Say find the rotational kinetic energy. So rotational kinetic energy KR equal to 1 over 12 2I omega square. So we are given what? I to be 6.5. Omega is what? 2 pi times 500 over 60. Why are we doing by divided by 6 per minute all square? So what I would have now 1 over 2 times 6.5 times 2 pi times 500 divided by what? 60. Divide by 60, then square it, then times 6.5 divided by 2. So I would have it as 8. So everything now all together give us what? 8910.05, which is approximately what? 1, 2, 3. So we have 8.91 kilowatt joules. So I'll go with option A. Number 23. Number 23. It says that what? A centrifuge rotate what? At an angle speed of 3600 what? Rev per minute. When switch off, it rotates 50 times before coming to rest. Find the constant angular what? Acceleration of the centrifuge. So that's what we are looking for. Now this question, they've given us what? The angular speed as what? The first one was given as 3600, so multiply by 2 pi, convert to what? Rad per second. So that is initial. So I'm going to have it as what? 2 pi times 3600 divided by what? 60. And that will give us what? 120 pi rad per second. Now when the switch off, when the switch was now off, now what happened? It rotates what? 50 times. That means number of revolutions is 50. So theta is equal to what? 2 pi n. 2 pi n. So in that case, if what? Our 2 pi n is what? Is our number of what? Angular displacement formula. Therefore, we can now say 2 pi what? Times 50 is equal to what? 100 what? Pi. Now, having gotten that, now what we're going to do now is to what? Now is to solve for what? For the constant angular acceleration. But they say what it comes to rest. So that means W final be equal to 0 rad per second. Then what is meaning? Alpha is unknown. So W final square equal to W initial square minus 2 alpha theta. Why am I using minus? Because it decelerates. So W final is what? 0 square. W initial is what? 120 pi all square minus 2 times what is alpha? Unknown. Theta is 100 pi. So what I would have now, alpha becomes 120 pi all square divided by what? Divided by 2 times 100 pi. So what do we have now? We're going to have it as what? 120 pi 2 times 100 pi. Then square the numerator. The 120 pi will be squared. So we are going to have 72 pi, which is equivalent to what? 2 what? 6.19. 226.19, which is approximately 226.2. So if you do it well, I don't think there will be any problem. 120 pi square divide by what? 2, then divide by 100, then divide by pi. One twenty pi 2 times 100 pi. So 120.2. We are going 0.19. But what I'm having in my option, that's why I'm even doing it again to be very sure. I'm having 226.1. I'm having 226.21. I'm having 2, and I'm having none of the above. From what I'm solving here and what I've confirmed here in this question, I would rather pick none of the above from what I've seen. 24. 24 says a flywheel of mass 100 kilogram is rotating about an axis at 150 rev. So that means mass is 100 kilogram about an axis at 150 rev per minute. That means angular is given as what? 150 times 2 pi over 60. And it is acted upon by a constant frictional couple, so that after 10 seconds, that means time is 10 seconds. After 10 seconds, and what happens? It's rotating at 100 rev per second. You know what I noticed here? From 150 to 100, that is deceleration has occurred there. So that means W final is now what? 200 times 2 pi over 60. Find the what R, radius of gyration of the wheel. If the couple moment is what? Now, listen and listen so good. Now, we need to find alpha first, because our W final square called the W initial square minus 2 alpha theta. Why did I use formula? It is what? Decelerating. So in that case, if I want to find W final, 100 times 2 pi divided by 60, I'm going to have 10 over 3 pi. Then 150 pi times 2 pi, rather 2 pi divided by 60. I will have it as 5 pi. So we now have our what? 10 over 3 pi all square equal to 5 pi initial minus 2 alpha. What is theta there? Okay, we don't know theta, so this formula will not be suitable. The formula that will be suitable is W final equal to W initial minus alpha t. I think that this one will be better. So 10 over 3 pi equal to 5 pi minus alpha times 10, because we are giving time. We are not giving theta, so this one will not work. So alpha will now give us what? Now give us, take this one here, collect like them, let this one come here. 5 pi minus 10 over 3 pi divided by 10. If you make what? Alpha the subject of formula. So I'm going to have 5 what? Minus 10 divided by 3. 10 divided by 3 is what? 10 divided by 3 by all what? Divided by 10. So I want to have it as 1 over 6 pi, which is that. Now, if you have gotten that one now, what I want to do now is tau equals to what? I alpha. Now, tau is what? Which is I alpha. Tau is giving us what? Which is torque 50 equals to tau is what? 50. I is flywheel. Flywheel is what? 1 over 2 mr square. times what? 100 times what? Radius. Are we giving radius? Okay. We are looking for what? Radius of gyration. So better use this one, mk square. So let me remove this one, mk square. So that is our moment of inertia of the flywheel. So if you are using radius of gyration, just for any shape at all, you use that one, mk square. Now let's put it there, mk square times what? 1/6 pi. So what we are going to do is to what? Make k the formula. So k will now be what? 50 divided by what? The mass times what? 1/6 what? Pi. So what do we have? 50 divide by what? Divide by mass. What is our mass there? Our mass is 100 times what? 1/6 pi. So what is the square root of that? 0.98 approximately. If you take square root of both sides to make what? K the subject of formula. So your K will be equal to what? Number 25 said a flywheel of mass 1,500 kg. That means mass is 1,500 kg and radius of what? 22 meter is rotating twice every second. So that means the 1/2 radius of gyration. So I equal to mk square per second of that because of radius of gyration. It's 1,500 times what? This is k. Is 2 square, which will now give us what? 6,000. 1,500 times 4. 6,000 kg meter square. Rotate twice every what? Seconds. That means angular velocity is equal to 2 pi times 2/1 because frequency is 2 revolution per second. So twice every second means that 2. So 2 pi f. So that one would have 4 pi. Now, how long will it take to come to rest under frictional torque? So that means this one is initial velocity, then initial angular velocity, then final will not be equal to what? 0. So let's use what? How long? The time it will take to rest. Now let's find alpha. Alpha is equal to tau over I. Remember that tau equal to what? I alpha. I gave you this one before. So it's yourself. So this one now, tau is what? 60 Newton meter divided by what? What is our I? I is what? Moment of inertia, which is what? We have solved for this 6,000. So what will you have now? You have 60 divided by 6,000. So I would have what? 0.01 rad per second square. So now we can now solve for how long is time. So we can now see W final equal to what? W initial minus alpha t. Why are we using minus? Because it's deceleration that is occurring here. Come to rest. So this one now will not be what? W final is what? 0. W initial is 4 pi minus what? 0.01 t. So I would have 0.01 t. If you take it to this other side, cross multiply 4 pi. If I go start by 0.01, so t will now be equal to what? 4 divided by what? 4 divided by 4 pi rather divided by 0.01. So that will answer will be 1256 0.63 or 0.6637. So 1256.64. 64. None of the above. This is 65, is 64. This one now, if you want to solve this question now, I will just solve it halfway. Then you will finish it for me because I'll be very simple. What we are going to do now is what? The ratio of rotational to what? Rolling. Rolling is what? Both translational plus what? Rotational. So this is what we are looking for. Ratio of rotational kinetic energy, which is this one, divide by what? So what we are going to do is to find 1 over 2 I omega square over 1 over 2 NV square plus 1 over 2 I omega square. So what you are going to do now, your I is what? 2 over 5 mr square. So when you do it now, what you are supposed to have is equal to what? 5 over 7. When you do it at the end of the day, put your I here, put your I here, try that one and see what you're going to get at the end of the day. So your answer is supposed to be what? B. 27. Don't forget, before I go to 27, don't forget that fraction of rotation. The answer fraction of rotation is what we have just solved now. The same formula. But if I say fraction of what? Translational. Calculate the fraction of translational. Will not be translational kinetic energy over the total kinetic energy, which is for translational plus what? Kinetic energy of rotational motion. So that will give us the total everything. So in case you are asked, this one is the same thing as fraction of rotation. Now, what? Motion. While fraction of translational what? Translational kinetic what? Energy is what? This particular formula. Now, this other one too, I want you to try it. What is the time interval to stop a flywheel? Time interval to stop a flywheel which slow down at constant rate of this from an initial value of this. So you get your what? Initial value, which is this initial 150 rev per minute. That's 150 divided by 60. You get your angular velocity. Now, don't forget that you have been given alpha to be what? 2.0 rad per second squared. So very easy. Then W final is equal to what? 0. So what you are going to do for me is to find, using this formula, W final equal to W initial minus alpha t. That's what I want to use. So W final is 0. W initial is what? Is 1/5. Let's solve it. 2 pi times 150 divided by 60. 5 pi minus what is alpha? 2 t. So you just make that one the subject of formula. 2t will now be 5 pi. If I go start by 2, what we did, I will take minus to this other side, become plus, then the Bible start by 2 to make what? T stay alone. So I'm going to have 5 over 2 pi second. But let's press it in our calculator. 5 over 2 pi is what? 7 point what? 8 what? 5 seconds. So that will give us 7.85 seconds. Is 7.84. I'm going on the above. Don't ever maneuver anything there. So solve this one. When you solve this one, try this. Your answer will be R, option A. Because they say the moment of inertia of a thin cylindrical hoop is given as I. So in that case, what is the radius of gyration? This thin cylindrical hoop, don't forget, is mr square. Or if it's radius of gyration, mk square. For solid cylinder, it's mr square. Half mr square for solid cylinder. Or mk square. This is for solid what? Cylinder. For solid sphere, is 2 over 5 mr square. is equal to the same thing as mk square, solid sphere. Then we have what? 2/3 mr square for spherical shell. Spherical shell. We have another one called what? 1/12 ml square for about the center of a rod, uniform rod. But we have another one about its end is 1/3 ml square, where L is the length of the rod for both cases. We have other cases that you can just think of. So you note that this one is what? 1/2 ml square, 1/3 ml square about its end of a rod. This one is for rod. Then this one is what? Cylindrical hoop or ring or hoop. Then this one is for solid cylinder, this is for solid sphere, it's for spherical shell, and so forth and so on. So what I will do now is that we'll go to 29 immediately. Say a rigid body is said to be in mechanical equilibrium when both the translational and rotational equilibrium conditions are satisfied. That is when the what? The torque is equal to 0. The sum of the torque and sum of forces is also what? 0. Sum of torque is also what? Sum of moment. Don't forget, equilibrium satisfies two major things. The sum of moment about the system is 0, and sum of forces must be also what? 0. So that is the answer. You say what? The moment of inertia is at times called the second moment of mass, and it depends on dash, the perpendicular axis of rotation, 2, the shape of the body, 3, the distribution of mass within the body. Yes, the three of them are fully satisfied. So I will go to what? Option C as my answer. I believe you have enjoyed this from 1 to 30. Take your time to watch them over and over again and make your comment and make sure you type something at the comment section to complement this effort. Thank you. God bless you. If you notice anything, please quickly notify us and we'll give explanation to that. Thank you. God bless you.